Hi, welcome to the first video on congruent triangles. This video is on proofs with properties of equalities. Proofs with properties of equalities. The properties of equalities are, and I have two sections, I have numbers and geometry just to illustrate. The first property is addition. If A equals B, then A plus C equals B plus C. You're adding C to both sides of the equation. In geometry, if you have angle ABC equals TBF, then ABC plus CBT equals TBF plus CBT. So CBT is added to both sides of these angles of their measures. Or in a segment, PQ equals PR, then PQ plus QR equals RT plus QR. QR is added to both sides. And subtraction, if A is equal to B, then you subtract C from both of these by the subtraction property. If angle 1 equals angle 2, then you're subtracting 3 from both of these equal angles. Or if AC equals BD, you're subtracting BC from both of these segments. The transitive property, if A equals B and B equals C, then A equals C is the transitive. B is in each of these expressions, equations. So we have what we call transitive property. If angle P equals angle A and angle A equals angle F, then angle P equals angle F because they're both equal to angle A. Or if AB equals XY and XY equals PQ, then AB equals PQ because they're both equal to XY by the transitive property. Reflexive property, A equals B, that's in numbers, or angle 1 equals angle 1, or segment AB equals AB, or angle PQR equals angle PQR. So any number is equal to itself, or any angle measure is equal to itself, or any segment is equal to itself. And there are more properties. And number 1 would be substitution. If A plus B equals C and B equals X, then A plus X equals C. Notice the B is being replaced with the X. We call it substitution. Very similar to transitive, but a little bit different. If angle 1 plus 2 equals angle A, and angle 1 equals angle 3, then 3 plus angle 2 equals A. The 1 is equal to 3, so the 1 is right here is replaced with the 3. If AB equals BC, and if A plus BC equals AC, and BC equals PQ, then AB plus PQ equals AC, because BC in this equation, BC is replaced with PQ because they're equal. That's substitution, substituting in. Like you would in an equation, substitute the value of X. For X equals 2 in an equation, you substitute X in the place of, substitute 2 for X. We also have the segment addition property. If we have a segment AC, would be also on that segment. So segment addition means that AC is equal to AB plus BC, segment addition. You're adding up these two segments here to get the big one. Or we also have angle addition property, which is adjacent angles. Angle ATC is equal to ATB plus BTC. That's what this is saying. If you add these two angles together, you get the big angle. Angle addition property. We also have some definitions that we're going to use in our proofs. And one is the definition of perpendicular lines or segments. If two lines or segments intersect at right angles or 90 degrees, if they intersect at the perpendicular lines are two lines that intersect at right angles or at 90-degree angles. Also, we have a definition of a right angle, and abbreviation for right, RT, angle. Angle with a measure of 90 degrees is a right angle. And the third definition of a midpoint. Midpoint, I would write MD, TP. The midpoint of a segment is the middle of the segment, dividing the segment into two equal parts. So I have this segment AC, M is here. If M is the midpoint, if M is in the middle, then MA equals MC. MA equals MC because the midpoint is in the middle. Or we have a bisector. Definition of we have two types of bisectors, a segment bisector. The bisector of a segment divides a segment into two equal parts. So if TF bisects PQ at F, if TF bisects this segment PQ at F, then FP equals FQ, because definition of a bisector. Or we can also have an angle bisector, divides the angle into two equal parts. So if AB bisects angle TAY, so if AB bisects angle TAY, then angle 1 is equal to angle 2. Or TAB, angle TAB is equal to YAB angles. So we're going to use these properties and definitions to help us do some of the early proofs that we'll need when we do congruent triangles. So let's do some examples. When you do proofs, you also look at what you're given and what you're trying to prove. So the given is that PE, this segment, is equal to FG. But we want to prove that PF, which is this segment, is equal to EG. So notice this is PE, which is small. FG is small, but PF is the large one. So notice that if you PF is PE plus FE, so we're going to have to do what we call add on. To make it bigger, you have to add. So when we do proofs, we have a statement. I'm going to call it 1 in a circle. So we normally put the given in the first statement. So that's the given. And the reason, well, it's given to us. Now, we want to get PF, so we'll take EF, which has to be added on. EF is equal to EF by what we call a reflexive property that we just practiced. It's the reflexive property of equality. That means, now how do I get to PF? Well, we want PF, but PF is equal to PE plus EF. So PF is equal to PE plus EF, and also that EG is equal to EF plus FG. So EG is equal to EF plus FG, and that's the segment addition property. Notice I did abbreviations for both of these. Segment addition. So if we want, we will look at 1 and 2 and we'll add. So we take PE and add on EF, and we take FG and add on EF. That's the addition property of equality. Addition property of equality. Again, here I wrote out addition, here I did a shortcut add. And notice that we took I said 1 and 2, so in 1 and 2 I added them together. So I indicated that here. So if you add these together, notice that right here, they're the same, and they're the same. So if these two add together to give you these two, there they are there, that means that PF is equal to EG. And that's what we call the transitive property of equality. I just say transitive property of equality. Again, we're doing of equality. So that's one proof. Again, notice you look at what you're given, and you look at what you got to prove, and size it up what you have to do. And B, notice we have a diagram with angles in it, and it's given. And I put down the given first. Angle ACF is equal to angle BCT. So that's the given. Now, what do we have to prove? We have to prove that ACB is equal to FCT. So ACF is the big angle, and ACT is the big angle. We want to get to ACB, which is a small one. So that means we're subtracting. So notice I got angle 1 right here, and that means I'm going to subtract because I'm going from a large angle to a smaller angle. So angle 1 is equal to angle 1. And again, that's the reflexive property of equality. And so if I take angle ACF and subtract angle 1, and take angle BCT and subtract angle 1, oops, that's number 3. That's the subtraction property of equality. And number 4, because we subtract, then if we subtract, that means that angle ACB is equal to angle FCT by, we could say substitution, we could say substitution property. So notice we're going from a big angle down to a small one, so we're subtracting 1 from it. Okay, let's do some more. Here we go. And C, we have A, B, C, T, all lying on the same segment, AT. We're given that B is the midpoint of AC. B is the midpoint of AC. C is the midpoint of TB or BT. And we want to prove that AC equals CT. So again, we got a given. We can do all the givens in one, or we can do them separate. Let's do them separate. I could put the barred area indicate segment or leave it off. So that's a given. So what happens as a result of a midpoint? If B is the midpoint, that means that AB equals BC. Definition of midpoint. So we have this segment equals this one. And we write down C is the midpoint. That's the given. C is the midpoint of BT. Given. And number 4, if that's a given, then that means that BC equals CT. And again, definition of a midpoint. So now notice that if we look at number 2 and we look at number 4, so we're looking at 2 and 4, that BC is in both of them. So if AB equals BC and BC equals CT, that means that AB is equal to CT by transitive property of equality. Transitive, T-R-A-N-S-I-T-I-V-E, transitive property of equality. So just look around, see what you have to do. Why did they give me a midpoint here? Midpoint, the two of them are equal. Why did they give me this point? Makes the two midpoints, makes this a midpoint, makes these equal. So notice I marked these with a stroke. And then I mark if C is the midpoint of BT. If that's a one stroke, then that's a one stroke. So you can see that all these segments, AB, BC, and CT are all equal. So there's the proof. D, we have a diagram, TAH, and we have the ray AB, and we have two. Now, the only reason I named the angles with 1 and 2, it makes, instead of going TAB, if I name it 1, it's easy to see angle 1. If I say angle 2, then it's easy to see that BAH is angle 2. If, for instance, if I'm just going to show you this, if I did this, that means that TAH, this two bars here like this, is going through the angle BAH. So when I say 1 and 2, then I mean just these two smaller angles. So we have a given. AB bisects TAH. So AB bisects TAH. Bisect means that two angles are going to be equal. So how am I going to get to, I got to prove that the measure of TAH is twice angle 1. So that means I have to use, let's see, let's try the bisector. Bisector makes it two angles equal. So we bisect angle TAH. That's a given. So that means that if I bisect angle 1 is equal to angle 2, definition of an angle bisector, because you're bisecting an angle, we say angle bisector. If we're bisecting a segment, we would say segment bisector. Now, how am I going to get to this? Well, we need the angle TAH, and again I can use measure, leave it out. Angle TAH is made up of angle TAB plus the measure of BAH. And so that's the angle addition property. We're adding the two smaller angles together. And notice I could have said that this angle is the measure of angle 1 plus the measure of angle 2. So instead of saying this right here, it's better to use the measure of 1 and 2, because 1 and 2, because number 1 is right here. So instead of going TAB, name it angle 1. Instead of going BAH, name it angle 2, because we don't have TAB or BAH on this right side. Okay, so we have, notice, angle 1. Angle 1 is here, but we don't have angle 2. So that means that the measure of TAH equals the measure of angle 1 plus the measure of angle 1, because the measure of angle 1 is equal to 2, so 2 is being replaced with 1 by substitution. So we're taking angle 2 away and putting angle 1 in, and that's substitution. Substitution property, or just we say substitution. And notice we have the measure of angle TAH, and we have angle 1 plus angle 1, so that's 2 measure angle 1, and that's the addition property. We're adding them together. Angle 1 plus angle 1 is 2 angle 1s. So notice we had to use the angle addition property, but you could have used TAH and BAH, but I used 1 and 2 because this has a 1, so therefore I use these two numbers. E, we have another proof. Let's see. BE bisects BE bisects AC. So BE bisects AC, that means these two, AB is equal to BC. prove that AB is a half of AC. Okay, that means I have to use the segment addition property and see what happens. So here we go. Number one, BE bisects AC, given. And again, we got a bisector, so AB equals BC. Definition of segment bisector. Notice segment, I wrote SEG instead of SEGMENT. I said just SEG. Now I need to get to this, so that means I have to say that AB is equal to, AC, my mistake, AC is the big segment, is equal to AB plus BC. AC is the big angle, AB the big segment, BC is the small one, so AC is equal to AB plus BC, and that's the segment addition property. And that means that if AB, we got AC here, we want AB, so that means BC has to be replaced. So AC equals AB plus BC is equal to AB. BC is equal to, or AB is equal to BC, so BC is replaced with AB. Notice we have no BC in here, so that's a substitution property. And as a result, we have that AC equals 2AB, and that's the addition property of equality. And we have that BC is a half of AC, so that means we have to divide by 2. So divide by 2. So BC divided by 2 is 1. AC divided by 2 is a half. And so that's the division. Division property of equality. And the proof is done. Okay, let's continue. Now we have more proofs. So if you want to pause your video and work these proofs out, be my guest. And again, look at what you're given, look at what you got to prove, and see if you're going to have to add or subtract, or use the segment addition or the angle addition property, etc., etc. Here we go. Given that AT is equal to BH, we have to prove that AB is equal to TH. So now that's the large segment, and we're going to the small one. So it looks like we got to do a subtraction. So here we go. We got to put down the given. Normally, the given. Again, I put the bar above. You can leave the bar off. The bar only indicates that as a segment we're talking about. If I said AT, we would still mean that we're talking about the segment. And we're subtracting, notice BT, so we'll say that BT equals BT. Reflexive is equal to itself. And if we take AT and subtract BT, we take BH and subtract BT. That's the subtraction property of equality. So we have subtraction. So what we have, AT minus BT, AT minus BT is AB. And BH minus BT is equal to TH. And that's substitution. Again, check with your teacher if you're allowed to say what I'm saying here. But we did a subtraction property, and we know that these two being subtracted will equal AB, and these subtracted will equal TH. So ask your teacher, make sure. If not, you might have to do a little bit different. Number 2, again, pause your video and see if you can do your proof or follow what I'm doing. We have angle 1 equals angle 3, and we want to prove that XTV, which is the big angle, is equal to WTH, so we're doing an addition. So, there we go. Let's look. We have number 1 is angle 1 equals angle 3. That's a given. And we have angle 2 equals angle 2 because XTV is made up of 1 plus 2. So we have to say 2 equals 2 reflexive. Again, it's the property of equality. And we take angle 1 and add on angle 2. Take angle 3 and add on angle 2. And that's the addition property of equality. Addition property. We could say reflexive property if you want, just to make. Now, angle 1 plus angle 2 is XTV. So I could do XTV right here, and I could do WTH. Or, if I was saying about the other way, I can say that angle XTV is equal to angle 1 plus angle 2, and WTH is equal to angle 3 plus angle 2, and that's the angle addition property. And that leads us to, notice that 1 plus 2 is right here, 3 plus 2 is right here, and that means that XTV is equal to angle WTH, and that could be, if these two are equal and these are equal, that's the transitive property. STIT, transitive property, if I can spell right. Or you could have, again, check with your teacher. If you did these 3 steps and you omitted this one, and you went to number 4 here, 1 plus 2 is equal to this one by substitution. So check with your teacher about which way to go. Your teacher would want you to do. Number 3, this diagram, we're given that TB bisects AC. TB bisects AC. That makes this segment equal to this one. If AC bisects BH, that means that this segment equals this one. So how do we get AB equals CH? That's what we got to prove. Well, we're dealing with the bisector this time. And here we go. So it's TB bisects AC, given. Now, some teachers will I'll do it a little bit different. Some teachers will allow you to put all the givens in the first statement, like that. And then the next one is that AB equals BC and BC equals CH, and that's the definition of segment bisector. Again, check with your teacher. So if you put the 2 givens in here, remember, this one gives you this, and this one gives you this. Because this is a bisector, TB bisects AC, then these are equal. Because TC bisects BH, these 2 are equal. And again, check with your teacher. Because these are equal, notice BC is here twice. So that means that AB is equal to CH by transitive property. And why, if you put the 2 of them in one, like I did here and here, it just saves you time in writing it out. So check with your teacher. Number 4, we have all these angles, and we got 1, 2, and 3, naming different angles. Again, I put 1, 2, and 3 in here, so I wouldn't have to go angle A, B, C is 1, C, B, F is 2, F, B, T is 3, instead of naming with 3 letters. So let's look at the given. BC bisects A, B, BC bisects, a little error, that's an F, BCF, and BF bisects CBT, so that's an F there. How can BC bisect angle ABC? That's an F, my mistake, so that's an F. So if we got a bisector, that means if BC bisects ABF, that means angle 1 is equal to angle 2. If BF bisects CBT, that means 2 is equal to 3. Oh, and 1 equals 3. Oh, I can see now. Okay, here we go. So not too bad. BC bisects angle ABF, and FB bisects angle CB. Make sure I write it down right. And again, that's a given. And as a result, because of BC bisecting ABF, angle 1 equals angle 2. Because BF bisects CBT, angle 2 equals angle 3. And that's the definition of an angle bisector. Notice I got the angle symbol. And number 3, angle 2 is here twice, so angle 1 equals angle 3. If angle 1 equals angle 2 and angle 2 equals angle 3, that means that 1 equals 3. They're all equal. And the reason is transitive. So just a little error, that C should have been an F. Okay. I proofread, but I still missed it. That's what happens sometimes. Hopefully it doesn't happen when you write a quiz, but if you wrote a quiz and that happened, as a teacher, I would give every student the full marks. If I make a mistake, the student gets full credit for that question, but I didn't discussing it. Let's do some more. Pause the video and work these out. A, B, C. It says that B is the midpoint, and B is the midpoint. That means that AB equals BC. Proves that AC equals 2 times BC. Okay, that means we have B is the midpoint of AC given. Again, now if you pause your video and work these out, you can see how to work them. That means that B is the midpoint. That means that AB equals BC. Definition of a midpoint. And we got AC is the full segment, so AC is equal to AB plus BC, and that's segment addition property. And notice that AC, we got an AB, 2 times AB, but BC is not there. So that means I have to put AB in the place of AC. AB is equal to BC. BC is being replaced with AB by substitution. S-U-B-S-T-I-T-U-T-I-O-N. S-U-B-S-T-I-T-U-T-I-O-N. Sometimes I go to spell and my spelling doesn't work correctly. Now that means that AC is equal to AB plus AB is 2AB. And that's addition property. We add them together. Okay. And number 6. Now we have a diagram here. You can see angle 1, 2, 3, 4. And we're given that AB bisects HBV. AB bisects HBV. So that makes that angle equal to that one. And we got AB is perpendicular to TW. So if AB is perpendicular to TW, perpendicular means you have right angles at TBW and TBT are right angles, making the angles equal. TBW and TBT are equal. So we have to prove that 1 is equal to 4. So let's see, we gotta get the big angles equal. So let's do the given first. AB bisects angle HBV given. And if that bisects, that means that angle 3 equals angle 2. Definition of an angle bisector. Okay, so how are we going to get, why did they give us AB is perpendicular to TW, and that's a given. Notice this time I didn't put the givens all in one because I'm using them separately. So if that be the case, that means that angle ABW, because they're perpendicular, angle ABW is equal to 90 degrees, and angle ABT is equal to 90 degrees. And that's the definition of perpendicular segments or lines. The lines or segments are perpendicular, then they form 90-degree angles or equal to 90 degrees. So you could say they're a right angle or equal to 90. That means that angle ABW is equal to angle ABT, and that's transitive property because they're both equal to 90 degrees. Transitive property. And let's continue. Now, if I take angle ABW and subtract angle 2, that's a subtraction there. And I take angle ABT and subtract angle 3, that's the subtraction. It should be TR, subtraction property of equality. And if I subtract ABW subtract 2, that means I get angle 1 equals angle 4. Whoops, my mistake. There's a 4 there. Angle 1 equals angle 4 by substitution. It should be STITUTION, substitution. And again, I did it without saying that ABW is 2 plus 1, and ABT is 3 plus 4. I just said that ABW subtract 2 is angle 1 by substitution. Okay. And the last proof, prove all right angles are equal. So what happens here, I made a statement, and the given here is that I have all right angles. So I have angle 1, I wrote it out for you, that this is a proof that if I gave you, I just apologize, if I gave you prove all right angles are equal, you would have to come up with, given 2 right angles, 1 is a right angle, 2 is a right angle, and prove that 1 equals 2. So I'm all right angles are equal, so you're given that angle 1 is a right angle, angle 2 is a right angle, and that's a given. You're given all right angles, we've got to prove they're equal. So because they're right angles, that means that angle 1 is equal to 90 degrees, and angle 2 is equal to 90 degrees. And the reason for that is the definition of a right angle. because a right angle is equal to 90 degrees. And since angle 1 is 90 and angle 2 is 90, angle 1 is equal to angle 2 by, they're both equal to 90, they're both by transitive property. Notice you're given two right angles, so you just can't say because you're given right angles you make them equal. You have to do it in a roundabout way. So to say that angle 1 is a right angle, you make angle 1 90 degrees because they're both 90s. Now I can use the substitution. So I had to do this in between step. Other than that, I would just prove the statement by writing the statement, but this, you got to do it in another roundabout way. And that brings us to the first video on doing some proofs and leading to congruent triangles. And I hope you enjoyed my video. If you did, click the like button, subscribe button, notification bell, visit my website www.mathfullyexplained.com to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you very much for viewing my video. Bye bye.